Okay, so I'm playing with the timers of 8051 microcontroller, and the LED, you see the blue LED, it's blinking at a rate of 50 Hertz, and I just did this with polling method using Timer0 of AT89s52, and I can show you the frequency. Yes, so that's about, I can't hold the two probes, so it's jumping out about a bit. Let's see if I can hold two probes. One here and one there. No, I can't move the camera. Let's see if I can. It's gone. Anyway, so 50 Hertz, about 50 Hertz, 50.8. Now here's the code. So I defined LED port 10 as LED, so that's what I'm toggling, and this is the main function. Initially it's 0 and the state is changed, and this delay, this is a 10 millisecond delay, so 10 milliseconds is gonna stay high, and for 10 milliseconds it's gonna stay low. So 20 milliseconds of period means 50 Hertz signal. First I did I put a value in the T mode register, and that is from this one. Yes, this is the data sheet, and this is the T mode register. So modifying this to 01. So 01 is 16-bit timer counter mode, and all the else is unchanged. I think you can't access this register, bitwise access this register, so you have to write all the 8 bits. And then I put the value, high and low value of the starting point of the counter or timer, and that is here, right here, TH0 resistor, so it contains the Timer0 high byte resistor and TL0 resistor, and these are 8-bit resistors. So yeah, so we started counting up from this value, the value stored in TH0 and TL0, and we'll count up to 65536 and overflow, and let's see if this zooms. No. Yes. Okay. So TH0 and TL0 has been filled with a value. I'll show how that value can be calculated. Then we have TR0 bit. This is bit accessible, so we're accessing the bits, and TR0 is in TCON, I think, TCON register. It starts the timer. Then TF0 is another bit that is the flag bit, which sets when the timer 0 overflows. So we're waiting for it to overflow and set the TF0 flag, and then we are stopping the timer, and we're also clearing the flag bit, and this is my delay of 10 milliseconds. And how did I get the time required? Well, this is simple calculation. Let's just get the pen and paper out. So my clock frequency is 16 megahertz. Machine frequency is divided by 12. So 16 megahertz divided by 12 gives something like this. And if we want to find out the time, just inverse it. Time period is 0.75 microseconds. So the timer is counted, incremented with each machine cycle, so 0.75 microseconds. The timer is updated every 0.75 microseconds. So for a required delay of 5 milliseconds, what we need to do is find out how many increments does it take to reach 10 milliseconds. So we simply divide 10 milliseconds by 0.75 microseconds to get the value where the number of ticks that is required to get 10 milliseconds. So 10 milliseconds divided by 0.75 microseconds, that gives us 13,333. Okay, so this is the amount of, or this is the number of ticks required to get 10 milliseconds. So it's a 16-bit resistor because we've just selected mode 1, which is a 16-bit timer. So the highest count it can go up to is 65536, and so we need to start from a value. Let's say this is our start value and this is the top value, and in between we want this amount of ticks. So that's simple to figure out. 65536 minus 13333, so 52203. This is the value we need to start counting up from. If we start from here and go up to 65536, then we have counted up to 13333 ticks of the timer. So let's just convert this to hex, base decimal 52203, and hex is CBEB. So this will go to TH0 and this will go to TL0. That is what we've done. TH0 is loaded with CB and TL0 with EB. Now we are doing the polling method, so we're always looking out for we're always monitoring the flag bit of the T-con register, but we are not doing anything else. What we've we need to do something else instead of just spending all the processing time on this single line. For that, I think we would need interrupt, and timers have the timer registers have some interrupt functionality that we can use to achieve the goals we want. So I think the next thing will be using timer with the help of interrupt. Yes, thanks for watching.